Hello, I'm Peter Violano,
I'm Brian Rowe.
and this is the 2023 RBC Smart Cam Follower Bearing Capstone Design Project.
The team has been tasked with creating and testing a load sensing cam follower bearing, which will be used in highly dynamic systems in the canning industry. The load sensing bearing will allow for preventative maintenance that will decrease machine downtime and does so without the need for system simulations, which are unreliable in such complex systems.
Previous teams had created load sensing cam followers, which had two strain gauges, one at 0 degrees and one at 180 degrees on the cam shank. The 2023 team was tasked with reinforcing the test rig and validating the previous team's results. The team then proceeded with creating and testing an improved load sensing bearing iteration. The improved iteration decreased and cleaned up the amount of machining done on the cam follower in order to improve bearing strength and added an additional two strain gauges onto the bearing.
The rig is composed of several components that replicate the machines used in the canning industry. A motor was used to rotate a cam underneath the bearing, which was pushed into a set of four springs as the cam spun. The springs added adjustable radial load onto the system, which a load cell read for comparison to the strain gauges.
The strain gauges were epoxied onto the flat surfaces cut into the bearing shank, and the bearing was tested on the rig. The resulting data was then examined in two main ways. One, how the bearing reacted at varying torque values placed on the nut of the bearing shank, and two, how close the strain gauges read load compared to the load cell.
Finite element analysis simulated multiple theoretical radial load cases with various amounts of nut preload torque. This is accomplished in a two-part simulation. Data was then analyzed in Excel to construct trend lines used in LabVIEW programming. Thank you.
Thank you.